Oh, you
That moment when you tap it,
it looks like you just gently set it down.
but like, I'll put it in my pocket in my barrier because
All right, today we're going to wrap up 4.6, and we're going to be able to start our last section of the unit, okay, 4.7. Since it's the last section of the unit, I think I warned you guys yesterday about the quiz and test coming up. Is that right? No. Okay, so I did that first period, but I forgot to do it for you. We're nearing the end of a unit, which means partner quiz and unit test coming up next week, and I think into the following week. So my game plan, which I think we'll be able to stick to, is we're going to start the last section today. We're going to finish it Monday, which means Tuesday is going to be a free response day. Wednesday is partner quiz. Thursday is review day. And then Friday and Monday the following week will be unit tests. Okay, so I'm giving you about a week heads up for the unit test, but partner quiz the middle of the week next week. Do you want to switch them?
Because that way we have the review.
See, the reason I break it up is because the partner quiz gives you a chance to... So the free response day is acting like your review for the partner quiz. And then if we're still stuck on something after the partner quiz, then the review day takes care of that for the test. Okay? All right. So, in the meantime, let's take a look on page 279. Yesterday we were trying to start with an equation and either graph it. Is it eating your pencil?
Yeah, well, the one pencil just wasn't sharp.
Yeah. Has a mind of its own sometimes. We either started with a graph and tried to write the equation, and then we were given an equation and then we were trying to graph it. Okay, so we're trying to go through or translate or go through these different types of representations. So 279 is going to be another example of where we start with an equation and we're going to try to graph it. We'll take a look at some slant asymptotes a little bit more today just for extra practice, and then we'll officially start our last section. Okay, so very similar to the setup of the one that we saw yesterday, we're going to start with this rational function, and then our ultimate goal at the bottom is to get a good picture of what it would look like. So to start this off, it'd be very nice if we could pinpoint some different characteristics that we can put on this graph, and we really need to factor the function in order to figure out most of those characteristics. So maybe we'll start off by doing that. We can't really factor the top. It's already as simple as you can get it. What about if we tried to factor the bottom? Good, Lainey? X plus 2, x plus 4. Good. All right, so let's roll through our 5 different characteristics. Okay, first we'll tackle vertical asymptotes. Can we find one somewhere? Good, Logan? Say it again. -4, good. Because? Say a little louder, I can't hear you over the vent. So the x plus 2's cancel, which means the x plus 4 is left over. Okay, so we'll say x plus 4 is left over in the bottom. All right, so there's a characteristic. Let's go ahead and graph it. So vertical asymptote at -4. Now, speaking of that x plus 2 that canceled, that's probably signifying a hole. So that would be at -2. So we'll say because x plus 2 cancels. Now, if we tried to graph the whole, we just know it's somewhere here at -2. We don't really know the height of the open circle, but can we figure that out? Do I got to put the hole somewhere up top, somewhere down below? How do I know where it is? What do you think, Blair?
Use the simplified version
Of the, there we go. Okay, so we said the x plus 2's go away. We can cancel them out. So we're left over with technically a 1 placeholder up top because the factor went away. And Logan said that the x plus 4 would be left over in the bottom. So here's our simplified form. If we were to plug in -2, we'd get a half. So we can now put our open circle -2, half somewhere right there. All right, so 2 characteristics down, 3 to go. What about any horizontal asymptotes? Good, Lainey? Okay, so if we look at the original function in standard form, we notice how the power on the bottom is more than the top. So if we have a bottom-heavy function, okay, the bigger power's in the bottom, it's always going to be at 0. So we'll put a horizontal asymptote on the x-axis. 3 down, 2 to go. What about any x-intercepts? What do you think, Caitlin? Why? Okay, so we said -2 was a hole, and -4 was a vertical asymptote. Those make the bottom 0, but those aren't on the x-axis. We've already dealt with those. Can you help her out, Lainey? Okay, so if we do 2 divided by 8, that would be 1/4. When you divide the constants, that's a y-intercept. So that's actually a 5th characteristic. We'll go ahead and plot that. So y-intercept 1/4, somewhere right there. What do you think, Lizzie? Why? Okay, so if the horizontal asymptote is on the x-axis, that's a spot that you're going to approach, okay, not necessarily touch. So if we're never going to touch the x-axis, there's no way we can have an x-intercept somewhere there. Okay, so none will say because horizontal asymptote at y equals 0. Can we think about a different reason, perhaps, as to why we don't have one? There are some examples where we do have a horizontal asymptote at 0 and still have x-intercepts. I think we saw one before. I'd have to dig deep for it. What do you think, Logan? There's nothing else left over. Okay, so a leftover factor in the bottom is a vertical asymptote. A leftover factor in the top is an x-intercept. And notice how we didn't have any factor left up there. We had that placeholder of 1. So we can say because no leftover factor on the top. Okay. Now, for the purposes of this example, I would take that there's a horizontal asymptote at 0, but there are some graphs that still have a horizontal asymptote at 0, but have x-intercepts as well. So we kind of have to be a little careful with those. I'm going to try to search through and see if I can find one. I swear we had one before. Yeah. See, what I thought of was this one, but this horizontal asymptote's at 1.
There was one that we had.
I know. I swear there was.
Really far back.
I'd have to look back. Okay.
Like 1.1.
Let's see. Maybe I can find it. I don't know. Maybe I'll try to make one up and show you in a little bit. Let's see.
One on
248? Is it a physical graph?
Yeah, there's no, it's not, like, it's on one, but it does cross over. That one.
Oh, I see. See, I'm trying to find a horizontal asymptote of 0, but it still goes through the x-axis.
There isn't one.
Where did she just give you? This table. Next page. Write random numbers down for like big numbers.
What's up? Yes. All right, here's one. Might be a little hard to see. All right, so it could be a little tricky. Again, your calculator can only do so much. Technology can only go so far, at least with its capabilities. So here we have a vertical asymptote at 1, 2, 3, 4. It looks like 5. Vertical asymptote at 5. Vertical asymptote at 3. Horizontal asymptote at 0, because that's what we approach on the left and the right. But we do have an x-intercept somewhere in here. Okay, so a little different. Just because you have a horizontal asymptote at 0 doesn't mean you don't have any x-intercepts, because here's a counter example. So this reasoning would work for this example, but just keep in mind it might not be for everyone. Okay, this reason though is sound. Okay, every time that would be the case. Okay, but I'll accept the other one for this example. All right, so we rolled through all 5 different characteristics. Let's see if we can tackle domain and range. Without even finishing the graph, we should have enough information to help us determine what numbers we have to skip over. Instead of saying the whole thing, can we just mention perhaps the numbers we have to skip over for the domain? The numbers that don't work if you drag your pencil left to right? Yeah, you could do all real, except, yeah, all real numbers except what? -4, -2. Okay, so I know that we've done interval notation, and you can definitely do that. Okay, negative infinity, positive infinity, skipping over these. You could say it kind of in mathematical language, all real numbers, okay, the double-stemmed R, except these 2 values. Okay, it represents the same idea, just using a different notation. Can we maybe do the range? What numbers we'd have to skip, low to high? All real numbers except y equals this time. What do you think, Lenny? 0? Okay. And 1/2. Okay, so we have to skip the horizontal asymptote and the y value of the whole. Looks good. So maybe some of you prefer that notation instead of the intervals because it's a little quicker. Up to you. All right, let's go ahead and finish our graph. So just so we're accurate, I want us to be able to have 3 different points on each piece or each branch. So we can anticipate a section showing up in this top right-handed side. And I don't know if we've kind of noticed a pattern yet with these rational functions. Normally they are diagonal to each other. So if we have a section in the top right, that probably means we're going to have another section in the bottom left. Okay, there are some examples though where they are next to each other. Okay, that's another just an interesting fact for some of these cases, but they're usually diagonal. So on this top right hand side, we already have 2 points that can help us draw the section. Can we find a third one? What number are we feeling today on the right-handed section? Good? 5? Sure. Okay, we'll go all the way out here. So take the time. You can plug in 5 into the original. You can plug in 5 into your factors, or you can plug in 5 into our simplified form, okay, that we'd use to help us figure out the whole height. So I think that one's going to be simpler. 1 over 5 plus 4 would be 1 over 9. So all the way at 5 over here, we'll have to plot 1 over 9, which is pretty close to the x-axis, so just get as close as you can, I guess. So if we think about what this section is going to look like, we're going to play connect the dots, being close to the horizontal asymptote. And then after the hole, we cannot go past the vertical asymptote. So we get this L-looking shape. Alright, so we're done with that side. On the left-hand side, though, we don't have any guiding points, so we basically got to pick 3 for this one. What 3 numbers do we want to try for the left-hand side? You just want to do -5, -6, -7? Go in order? Okay. So 1 over -5 plus 4, 1 over -1, which is -1. Alright, so -5, -1. 1 over -6 plus 4 would be -1/2. And then 1 over -7 plus 4, -1/3. Alright, so hug the asymptotes and connect the dots. There's our graph. If you wanted to double check it on a graphing calculator, you could. Just be aware that the hole is not going to be visible on the graphing calculator. Did we do that yesterday? Yeah, okay. I always forget. What do I do first period? What do I do third period? It's all kind of mixed up. Alright. Good review from yesterday, because we did one of those. I'll take the silence as a yes. Okay. Take a look at the back. Just kind of reviewing slant asymptotes a little bit more, because the graphs that we've done yesterday and just now didn't really have those in it. So just to reiterate that we do have a third option for an asymptote. Okay, it could be slanted, not just vertical or horizontal. Based off this graph, can we find the location of all the asymptotes? So this is actually kind of similar to what your calculator would do. Your calculator does not actually show in the imaginary dotted lines. Okay, so can we figure out where those might be? Sometimes ones are easier to find than others. Can we find an imaginary dotted line somewhere? Good, Lainey? -3? Somewhere right here? +3. Okay, there we go. I like that one. Alright, so that's a vertical asymptote. X equals 3. Can we identify another type of asymptote somewhere? It's slanted, right? Now, I don't really know how slanted it is, so I'm not going to try to draw one in. We do have a way, though, to figure out the equation exactly, and maybe once we have that equation, we'll draw it in. How can we find a slant asymptote? Synthetic division. Okay, so what's our number on the outside? I think I heard it. 3. All right. And then coefficients from the top. Let's drop 1 and we'll go through division. All right, now that I'm done with division, where do I actually find the equation of the slant asymptote? Where should we be looking for in those numbers? Say it again. Why? Coefficient. Okay, so check this out. We're going to ignore the remainder. That just tells us if we have a factor or not. And we're going to take a look at the remaining quotient values. So some of you might think, oh, the slant asymptote is 1x minus 4. Okay? Double check your work. If you actually graphed this, check this out. You'd have a y-intercept at -4 and a slope of 1. Does that look like a slant asymptote for the graph? Definitely not. Okay, so there has to be something else that needs to be done to this because it doesn't work out based off the picture. So this coefficient of -2 on the bottom, we're going to have to divide that, and that's going to change our numbers. We're going to have -1/2 x plus 2. Let's see if that works better. So y-intercept of 2, slope of -1/2. That looks so much better than before. So we'll draw in those dotted lines. Good to go. Do you guys think you can do the bottom one? If you haven't already? Try it out, see what you get.
That's just kind of in the middle of nowhere. It's just like in the middle of like,
In the middle of nowhere, like, do you have it?
It's just shown there. I don't think it's anymore.
God bless you.
It's
Okay.
that's the
I would take an educated guess. Well, here's the thing, okay? If you have an x-intercept of top, that also should somehow be related to the horizontal because you have those coefficients that should be divided. So if this goes on to 2, you're going to need a 2 over 1.
Well, at the same time, you can just like, you can basically put any number on the
Well,
this doesn't have footage.
That's right, yeah, I know.
Yes.
this also affects your
But nobody, everyone bet that.
because if you distribute this through,
It's like playing Kincaid Rule against some of that main box, right? It's not worth it. You're gonna lose.
That's like, that's what I'm like, yeah.
so, I mean, as long as you do educated guesses and double checking your work and see well, maybe I'm going to be right, then
I'm watching push the kid aside, just watch the fight.
Did
Did you watch this weird
if
footage?
you did not put a 2
You gotta see this.
if you put a 2 here, you're
No,
going
but
to
someone who showed it to me.
I don't know if that's gonna work or not.
He has every single distributed footage of it. Every angle. He wasn't even here. I know, but everyone, he got all of it.
Yeah, no, it's gonna end up for sure, like that, that's what happened.
I'll have to get this.
That's
Josh,
that's
the
what
first one. They get it.
it's just that the leading coefficient should
Wait for
one,
one.
if it works out.
Oh, he took this way. He comes in with Kyle.
yeah, so they don't specifically tell us
Like if they said one or the other, like you
Yeah.
just why don't you just give me a slide. It's just like if we have one of those, I'm good.
That's just on top.
It's like on my chest, can you like,
I'll try to get
Can I see the video? I want to see my whole reaction.
okay.
Yeah, dude, this is fun. Awesome. I like my equations. That's not how that works. X does equal X. No, Y equals X. X equals X. It's like saying 1 equals 1. I mean, there's no point in saying
Yeah. Y equals X? Yeah? Checked out? Perfect diagonal line.
No, I actually wrote X.
All right, we're good to go. Let's go ahead. We're going to check out 4.7. This is going to be our last section of the unit. Now, I think this last section does not have a homework assignment attached to it, which is nice for you guys. And this last section, we are not going to be introducing anything new. This is more of like a holistic review of everything we've done. So we're just going to get comfortable and confident with these different characteristics related to equations and graphs and the whole jazz. Okay, so 285. The graph of rational functions to the right. We know this particular point and where the hole is. All right, state the domain and the range. Based off the graph, can we think of the numbers that we have to skip over? You can do interval notation. You can say all real numbers except, okay, just get your point across as to what the domain should be. Doesn't matter. Can we find the numbers we have to skip? What do you think, Caitlin? -3 and 2 for the domain because vertical asymptote and the x location of the hole. Okay. What about the range? Go, Blair? -7/5. What were those? The horizontal asymptote and the y value of the hole. Okay, they gave that to us at the top. Okay, so again, you can do all real numbers except. You can do interval notation. Completely up to you. All right, what factors are guaranteed to be in the denominator, aka the bottom, of the equation? We don't have an equation, but we can start to think about what the equation would look like. What do you think, Elsie? And? Okay, because x equals -3 is a vertical asymptote. Is there another one? X minus 2 because x equals 2 is a hole. Looks good. Okay, so holes in vertical asymptotes, those are restricted values, undefined locations, no physical points there, aka the bottom of a fraction is 0. Okay, it doesn't work. What about 3? What values of x gives this graph a value less than or equal to 0? Kind of a throwback question here. Can we think about what this is asking us to determine from the graph? What do you think, Lainey? All right, because h of x is below or on the x-axis. So that's our reasoning. That's what we need to look for. Now we actually have to figure out those intervals. So if we were to trace, because we have the picture, trace the sections where we are below or on the x-axis. Let's see. We can go all the way to the left, so -infinity. We have to skip over -3 because there's a vertical asymptote there. There's no physical point. After the vertical asymptote, we're briefly above the x-axis, so we cannot include that piece. but we're on the x-axis. What's that value? Do we know it? It looks like -1.5. Okay? They tell you at the top it specifically is because you equal 0. So we'll put a bracket there because we're on the x-axis. As we continue to trace, we have to skip over the hole because there's no physical point there either. And then the last remaining section will go on forever to the right, so we'll have 2 to infinity. So I know it seems like a lot of intervals, but it's kind of similar to how the domain and range look, where we have to skip over different places. All right, it's a throwback question, but just applied to a rational function graph. Because we did above x-axis, below x-axis towards the beginning of the year. Looking good. All right, let's try the last one. In standard form, find the equation for h of x. Give 2 reasons that support or confirm that your equation is correct. All right, can we start to think about maybe in factored form, and then we'll turn it into standard form, what this equation would look like? We already did part 2, or number 2, where we wrote down the factors that should be in the bottom. Can we think about any factors that should be up top? What do you think, Hadley? 2 is a whole, so we need x minus 2 on top and bottom. Looks good. Anything else? What do you think, Lainey? Okay, so the x-intercept was -1.5, so you could do x plus 1.5. You can change that to a fraction, which would be 3/2, like Lainey said, but similar to the divide and slide, we're going to move the 2 out front in front of the x. Okay, so Lainey, I like this, but we're going to move the 2. All right, so 2x plus 3. I like it. All right, so let's turn it into standard form. We're going to distribute, FOIL, combine like terms, the whole 9 yards. So 2x squared plus 3x minus 4x, so that's minus x and then minus 6. X squared plus 3 minus 2, so plus x minus 6. All right, here's our standard form. How can we check to see if this standard form is correct? We know the factors are good, but there are some other properties or characteristics we can check from the standard form. Can we double check it? What are some other things we can analyze? What do you think, Erica? Y-intercept. So what should our what is our y-intercept based off of this? 1, okay? What's the y-intercept based off the graph? -1. Uh-oh. Yeah. Okay, that's an issue. What's another characteristic we can check? Yeah? Horizontal asymptote. Okay, based off our equation, since the degrees are the same, we would do 2 divided by 1, which is telling us 2. Where's the horizontal asymptote here? -2. Uh-oh. Yeah. We know the factors are good, but these other characteristics are not checking out. So how can we get around that? Yeah. Do you notice how these numbers are off by a factor of a negative? Right? Okay, so if we know the factors are good, but these other characteristics are slightly off, that means there's some multiplier that is missing. And since these are off by a negative, that multiplier would be a negative. Didn't we see an example of that yesterday? Like when we had to multiply by 4, I think it was, in one of our first examples. Okay, same thing going on here. So this negative, if we were to distribute it in, is actually going to change all the signs on the numerator. So negative 2x squared plus x plus 6. Does that fix our issue? Y-intercept, negative 1. Horizontal asymptote, negative 2. Much better. Okay, so we'll go ahead and say those two reasons also confirm our equation. Okay, so we have to be careful. We can get the factors no problem. Okay, I'm pretty confident that we can do that, but we have to check the other characteristics. Sometimes you might need something else, aka a multiplier. We doing okay? For now, at least? Okay, we're going to save the rest of the section for Monday.